Okay, this is pre-calculus video on solving higher level polynomials in quadratic form. Okay, what that means is this is not a quadratic because it has an exponent of the power of 4. Okay, however, you can use a quadratic factoring method to solve this. And so we're going to factor this as if it were quadratic. And I already reviewed that with you when we did our factoring review. All right, this has 3 terms. It has no GCF. The leading coefficient is not 1, which makes this hard AC. I'm looking for factors of 6, whose sum is -5. 6 and 1, -6 and +1. No, that's not it, because they multiply to -6. How about 2 and 3? -2 times -3 multiply to +6 and add to -5. So first times first is 3x squared times x squared. Okay. So again, notice my first times first has to equal 3x to the 4th. So I'm breaking that down into x squared and x squared. Outer times outer has to be a multiple of 3. So the magic number that's a multiple of 3 is -3. So 3 times -1 in the outer position gives me -3. Inner times inner has to be -2. So I've got 1 times -2 in the missing inner position. And last times last is +2. All right, this is factorable. This is the difference of 2 squares. So I'm going to keep going. Bring down the first one because this is not factorable. And the square root of x squared, or excuse me, to factor x squared minus 1, I'm using the difference of 2 squares. Okay, so now it is in most factored form. Now I'm going to take each factor and set each factor equal to 0. So 3x squared minus 2 equals 0. X minus 1 equals 0. And x plus 1 equals 0. I'm going to have to solve 3 separate equations. All right. My first equation in red is a quadratic equation. This can be solved using the square root method because there's no b, okay? If there is a b, then you'd have to choose another method. But this is very easily solved using square root method. I'm going to isolate the square first. Then take the square root of both sides. Okay, so I've got positive and negative 2 over 3. The other 2 equations are very simple linear equations. And so there are 4 solutions. 1, 2, 3. 4 solutions because positive and negative radical 2 over 3 are 2 separate solutions. You know what I just realized? I'm not done with that. I'm going to insist that you rationalize that. Let me remind you how to rationalize. Okay, so here I've got positive and negative radical 2 over radical 3. You're not allowed to have radicals in the denominator. So I'm going to multiply top and bottom by radical 3 to get rid of the radical in the denominator. Radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is 3. Okay, so my final answer, positive and negative radical 6 over 3. x equals 1. X equals -1. It won't let me move it down. I'm trying. All right, you're probably getting tired of watching me try and move it down. And x equals -1. There's 4 separate solutions. Positive and negative, radical 6/3, positive 1 and -1. Now, this is too long-winded, but if I go back up to the problem, take a look at the problem. This had an exponent of 4, okay? The fundamental theorem of algebra told you that if we had a degree of 4 in our polynomial, there were a possibility of 4 solutions, okay? They may be imaginary solutions, but there exists a possibility of 4. Here we found 4 real solutions. All right, next problem. All right, this one's easy, AC. Maybe this will be a little easier, I hope. I have a feeling it won't be, though. I need factors of 6 whose sum is -7, -6, and -1. So since this is easy, AC, I should factor it a little easier. Y squared minus 6 times y squared minus 1. Okay. One of those is factorable, again. The difference of 2 squares here. Now I'm going to set each equal to 0. Y squared minus 6 equals 0. Y minus 1 equals 0. Y plus 1 equals 0. And solve each equation. So y squared equals 6. Take the square root of both sides. Y equals positive and negative radical 6. Y equals 1. Y equals -1. All right, again, this is 4 solutions. This was a little easier than the first one. 2 solutions for positive and negative radical 6. 1 solution for 1 solution for -1. And again, the degree of the polynomial was 4, so there were 4 possible solutions. All right, that's it.